Okay, so what we want to do, what we want to try and do is bring things together and condense them down where possible. So eventually we want to get to a point where we're only adding up the series numbers. Okay, so the first thing we're going to do is let's put our 3 and 4 together, since that way we can get one number for this green line. Okay, so because they're in series, R3 and 4 is going to be just really R3 plus R4, right? Which is going to be equal to 6. So 3 plus 3. So the reason why that makes this nice is because now we have a number for the green side and a number for the blue side. So we want to basically now figure out what is this blue and green section here together as one, because remember they're parallel to each other. So we want to do 1 over our 2, technically this is 2 plus 3 plus 4, right? We want this whole section. It's equal to 1 over R2 plus 1 over R3 and 4, which we already solved for. So this is basically the blue section in parallel with the green section. So I'm just going to put 2, 3, 4. So you're going to have 1 over 4 plus 1 over 6. So I'm going to just, well, I'll show the work anyways. But at this point, you should be okay with this. So we're going to have that be, so 1 divided by 4. 1 divided by 4 plus 1 divided by 6. Oops, sorry, by accident I typed that in wrong. 1 divided by 4 plus 1 divided by 6 is going to be 0.417, and then we're going to swap. So 1 divided by that answer is going to be R2 plus 3 plus 4 is equal to 2.4 ohms. Okay, so basically what we just solved for is this entire block. And now that we've done that entire block, we can actually solve for RT. Because 1, 2, 3, 4, we have a number for now. 5 plus 6 plus 7, the rest of this is in series. So to figure out the RT, it's going to be R1 plus R2, 3, 4 that we just solved for, plus R5 plus R6 plus R7. Okay, so your RT, I'm just going to plug this in here. So it's going to be 2 plus 2.4 plus 5 plus 2 plus 5, which gives us a total of, so 2 plus 2.4 plus 5 plus 2 plus 5, 16.4 ohms. Okay, so you break it down one section at a time until you get to a point where the rest of it is all in series. Okay, so try these ones out on your own. So for the ones I'm going to have you try out here are very simple first, and then we're going to, for your homework questions are actually going to be more like this one right here. And actually, if I'm not mistaken, I'll go through this again, but I'm pretty sure this is question 1 from your homework worksheet. Anyways, pause the video, give this one a try. So you're solving for the missing variables, and we'll see how you do. Okay, so number 2 and 3 are parallel to each other. And then, of course, number 1 is in series. Okay, so because number 1 is in series, you should have noticed that this should also equal 6 amps. So remember, they're on the same line. Once we have this fork in the road, right, we know that the current will split. Since we know that this current is 2, that must mean the other one is 4 because they need to add up to 6. Voltage in a parallel circuit is the same. So voltage is 8 for 2 and 8 for 3. Now because voltage at number 1 is 12, that must mean that the total voltage is 20, because no matter what pathway, it would be 12 plus 8 or 12 plus 8. Okay, now actually, since we have all the information here, or enough information, we can actually solve for RT by simply using Ohm's law, right? So V is equal to I times R. So R is equal to V over I. So this would be 20 volts over 6 amps. 20 divided by 6, which would give us 3.33 ohms. Okay. All right. Give this last one a shot, and then we'll see how you do. All right. So let's take a look. So we have, so again, it's very similar, just different numbers to work with here. So 2 and 3 are parallel, so the voltage should be the same. Our total current, we don't really have much information for current, actually, but we can figure out the total voltage. So total voltage is going to be 3 plus 9, which is 12 volts, right? Because no matter what path, it'll go through the 3 and then the 9. And then we can use V is equal to I times R to solve for some of our values here. So let's do I is equal to V over R. So we'll do for the total first. So if we do 12 divided by 10, right, we get 1.2 amps, which means that I1 is also 1.2 amps. And then, of course, we can figure out that I2 is 0.6, because 0.6 plus 0.6 can give us 1.2. Okay, so actually, remember I was mentioning that one of them will be repeated. In your worksheet that you are doing, which is right here, this question number 1 we've already done together. So this was actually the first example that we worked through in the lesson. So obviously don't repeat yourself, just continue and go straight to number 2 when you are doing these problems.